But if we wanted to make sure it gave us the same answer that we had before, we'd need to divide 9 into 109. So let's do that. I'm going to come over here and divide 9 into 109. I can change it back into a mixed number. 9 goes in the 10 one time. 1 times 9 is 9. Now I'm going to 19 2 times. 2 times 9 is 18. And I have a remainder of 1. So that means this changes into 12 and 1 9. 12 and 1 9. Having trouble seeing all of this. 109 ninths is the same thing as 12 and 1 9. Now if we go way back up here to this other part when we did it, you see we ended up with 12 and 1 9. So when you do it this way, you've got to end up carrying the extra whole numbers here. You've got to make the improper fraction into a mixed number and then carry the 2 over here to the 10 to get your 12 and 1 9. Down here you don't have to carry, just make everything improper fractions, but you do get much bigger numbers as you're going. So you have to decide whether you want to make everything improper fractions and get the bigger numbers as you go, or whether you'd rather keep things as mixed numbers. Now let's see what happens when we try to subtract mixed numbers. Okay, we first of all have to get our common denominator as we did before, and with 1/4 and 2/3 it will be 12. So let's go ahead and get our 12 down. So I have to multiply by 3, and that gives me 3/12. Down here I have to multiply both things by 4, and that gives me 8/12. Now, in this particular one we can't subtract 8 from 3, so that's going to cause us a problem. Now I'm going to come over here and rewrite this so we can see it a little better. We have 6 and 3/12, and we have 4 and 8/12. Now that we've gotten our common denominator, that's what we have left. And we can't subtract 8 from 3. So what we're going to have to do is borrow. So we borrow 1 from our 6, and that leaves a 5. But now, what we have to remember is the 1 that we're borrowing is actually going to be changed into 12s. I'm going to write the 1 up here to remind myself I'm borrowing 1, but I'm going to change that 1 into 12s. So the 1 is made up of 12 twelfths. So what's going to happen is, since I already had 3 twelfths, if I put the 12 twelfths with it, I'm going to end up with 15 twelfths. And now I want to subtract the 8 twelfths from that. Might better put that over here beside it. So if we do that, 8 from 15 leaves 7 twelfths, and let's not forget our whole numbers. 4 from 5 would leave 1. So our answer would be 1 and 7 twelfths. Now the reason we added the 12 twelfths here was we were borrowing 1 from the 6. The 1 that we borrowed had to have the same denominator as the other fractions we were working with. So if it's going to have a denominator of 12, its numerator has to be 12 too, so it will be equivalent to the 1 that we borrowed. Let's try another one. This time, our common denominator is going to either be 18 or some multiple of 18. And it looks like 18 is going to be okay, since 6 will go into 18. So let's change things to 18ths. So I have to multiply by 3 to get 18. So 1 by 3, that gives me 3/18. And down here, since I already have 18ths, I can just copy my 11 up there. Now, since I can't subtract 11 from 3, I'm going to rewrite the whole thing so we can see it better. It's 20 and 3/18, and it's 10 and 11/18. And again, you can see I can't subtract 11 from 3. So I have to borrow 1 from my 20, which means I'm going to have 19 left. And the 1 that I borrow has to be put over here with the 3/18. So I've got to add to that 3/18, that 1 that I'm borrowing. And that 1 has to have the same denominator as we're working with 18. So we've got to change that 1 into 18/18. So it'll be equivalent to 1. And so since we already had 3/18, we now have 21/18. And we had 11/18 here. So if we subtract the 11/18 from the 21/18, we'll get 10/18. And 10 from 19 will leave 9. And that will be our answer, except the 10/18 isn't reduced. So let's reduce it. Our answer is going to be 9 and 5/9. 9 and 5/9, because we can divide 2 into both the 10 and into the 18. Let's look at another one. 4 minus 5/6. Now, you might just want to put a 1 under this 4 and do it like you just have two fractions. But another way to do that would be to say you had 4 as your whole number and 5/6 as your fraction. And you might want to put a 0 there to help you see what you have. You don't have a whole number here, you just have a fraction. But you couldn't subtract that because you have to have something to subtract that 5/6 from. So what you would do is you borrow from the 4. The 1 that you borrowed would need to be changed to 6. So you'd actually have 6/6 to take the place of that 1. So 5/6 from 6/6 would leave us with 1/6, and 0 from 3 would leave us with 3. So we'd end up with 3 and 1/6. You could check that by adding 5/6 and 1/6 would give us 6/6. 3 and 0 would be 3. And if you had 3 and 6/6, that would be equivalent to the 4 that we had to start with. Now, as I said, another way to do this one would have been to put 4 over 1 and 5 over 6 and just get a common denominator and do it that way. And that would certainly work too. We have one last example. 7. Subtract 1 and 2/11. Now, doing that as a mixed number, we don't have anything to subtract that 2/11 from, so we have to borrow from the 7 and leave a 6. Now, the 1 that we borrowed has to be turned into 11s because that's our common denominator. So we need to change it into 11/11 because that'll make 1. And now we're ready to subtract. 2/11 from 11/11 would leave 9/11, and 1 from 6 would leave 5. So we'd end up with 5 and 9/11.